All right, let's jump right in. We all think we know pi, right? 3.14, the number from math class. But what if I told you to think of pi not as just some number, but as a character, someone with a whole life story that spans pretty much all of human history, from ancient puzzles all the way to today's supercomputers?
And, like any great character, Pi is, well, it's a celebrity. I mean, this quote from Star Trek, it just nails our obsession with it. Think about it. When you want to overload a rogue computer's circuits, what do you ask it? Not the square root of 2. No, you ask it for the last digit of pi. It's become our shorthand for the ultimate impossible problem. And that idea has totally captured our imagination.
And hey, it's not just a sci-fi thing, not by a long shot. Pi is literally everywhere in our culture. I mean, the US Congress actually made Pi Day a national event. Google, when they went public, their stock offering was based on the digits of pi. It shows up in The Simpsons, The Matrix Reloaded. People even made novelty ATM slips with a pi-themed balance. Seriously, think about it. Is there any other number, like not E, not the golden ratio, that's even remotely this famous? Nope.
So where did this all begin? How did a number get so famous? Well, Pi's story, its childhood, you could say, starts way back in the ancient world. And it wasn't some abstract idea. It was a really practical and honestly a super frustrating puzzle. Okay, so here's the definition we all had to memorize in school. Pi is the ratio of a circle's circumference to its diameter. Simple enough, right? You take the distance around a circle and divide it by the distance across. But for the folks trying to figure this out thousands of years ago, this simple ratio was hiding a really deep, kind of tricky problem.
And this right here was the first big challenge in Pi's life. It's something we totally take for granted now, but back then it wasn't obvious at all that the magic number you use to find a circle's area was the exact same magic number you use for its circumference. Proving that these two pi's were actually one and the same, that was the first massive hurdle they had to clear. And then a hero enters the story. Around 250 BCE, this guy, Archimedes of Syracuse, comes along. And he doesn't just solve the puzzle and prove the two pi's are the same. He also comes up with a way to calculate it that was so good, it basically set the standard for the next, 1800 years. Yeah, no big deal.
This is just pure genius. Here's how he did it. He knew he couldn't measure a perfect curve easily, so he decided to trap it. It's like he put the circle in a mathematical vise. He drew a shape, a polygon, just inside the circle and another one just outside it. He could calculate the perimeters of those shapes easily, so he knew pi had to be somewhere in between those two numbers. And the best part? He just kept adding more sides to the polygons. 6 sides, then 12, then 24, all the way up to 96 sides, squeezing the circle tighter and tighter and getting a more and more accurate value for pi. This was it, the world's first real algorithm for pi.
But look at this. This table tells the real story of how incredibly slow and painful this process was. I mean, we're talking about almost 4,000 years for humanity to crawl from knowing just one digit to knowing 35. 35! Getting just one more digit could literally be someone's entire life's work. This was it. This was the absolute peak of what you could do with geometry. So, after centuries and centuries of these tiny, hard-won steps, pi hits what you might call its adolescence. A massive revolution in math was just around the corner, and it was about to blow this whole problem wide open. And to really understand the moment, look at this. This is the tombstone of a mathematician named Ludolph van Ceulen. He spent pretty much his whole life using that same Archimedes method to get pi to 35 decimal places. It was such a monumental achievement, his life's work, that they carved the digits right onto his tombstone. It's really the ultimate symbol of the old way of doing things, right before everything was about to change forever. Because then, calculus showed up. In the 17th century, guys like Newton, Leibniz, and Euler came along with this brand new tool, and suddenly they didn't have to draw a million tiny-sided polygons anymore. They found a completely new way to see pi, as the sum of an endless list of numbers, an infinite series. It was a huge conceptual leap, moving from the world of finite shapes to the world of the infinite. And nothing captures this shift better than this quote from Isaac Newton himself. Get this. During the Great Plague of 1666, he's stuck in quarantine and he gets bored. So just for fun, he decides to calculate pi.
Using his new calculus methods, he just casually knocks out 15 digits. Something that would have taken someone like Van Ceulen a lifetime, Newton did basically because he had nothing else to do that afternoon. He even says he was ashamed to say how many digits he calculated. It was almost embarrassingly easy for him.
So this new power of calculus kept things moving for a couple hundred years. But the next really big chapter in Pi's life story, that comes in the 20th century, when its destiny gets tangled up with the invention of the computer.
Okay, so the formulas based on calculus really sped things up. We finally hit 100 digits, then 200, then more than 500. And then, 1949, ENIAC, one of the very first electronic computers, spends 70 hours just grinding away, and it spits out 2,037 digits of pi, an absolutely incredible achievement that was about to be made to look completely obsolete.
Because just look at what happened next. This is the digital explosion. The number of digits we knew didn't just grow, it went supernova. We went from a couple thousand to 100,000, then a million, then a billion, 100 billion. And by 2010, we were at 5 trillion. That slow, painstaking march through history suddenly became an all-out, dead sprint to infinity. So what was fueling this insane acceleration? Well, it was the discovery of these beautiful, incredibly efficient new formulas. A lot of them came from a self-taught Indian genius named Srinivasa Ramanujan. His formulas were just on another level. They were so powerful that every single step of the calculation could tack on another 8 or even 14 correct digits. It was like pouring rocket fuel into the new computer engines. So at this point, we've got trillions of digits on file, and the story starts to change. The big question wasn't, can we calculate more digits anymore? The answer to that was obviously yes. The new question was, okay, what do all these digits actually mean? What are they telling us? The quest shifted from just calculating to actually trying to understand. And that brings us right to the great modern mystery of pi. And the question is this: is pi normal? Now, normal is a math term, but it basically means perfectly random. Like, if you look at all the digits, does the number 7 show up just as often as the number 3? Does the sequence 8675309 eventually appear? This visual is a cool way to think about it. It's a random walk based on pi's digits. And if pi really is normal, this path should just wander around forever with no real pattern. And as far as we can tell, it does. But we have no way to prove it. Not yet. So just when everyone thought the next big thing would be finding some hidden pattern in the digits, a discovery in 1996 came along and completely changed the game. Again.
Okay, this next part is kind of mind-bending, so hang on. A new formula was discovered called the BBP formula, and it was like finding a cosmic shortcut. For all of human history, if you wanted to know the millionth digit of pi, you had to calculate all 999,999 digits that came before it. But this formula, it lets you calculate any single digit all by itself. You can just jump to it. You want to know what the quadrillionth digit is? This formula can take you straight there without calculating anything in between. It was a completely new way to think about this number. This incredible breakthrough suddenly made a famous idea from science fiction feel, well, a little less like fiction. You might know this from Carl Sagan's novel Contact. In the story, scientists discover a secret message from the creators of the universe, hidden deep, deep, deep inside the digits of pi. A message you can only see when you look at the numbers in a different way, in a different base system. And really, that's where pi's story is today. We've gone from struggling to get one digit right to having trillions of them, and now we can even jump to any spot we want in this infinite string of numbers. But that idea from Carl Sagan, it kind of lingers, doesn't it? This whole journey has been about our own endless curiosity, with every generation peeling back another layer of the mystery. Which leaves us with the one big, ultimate question: what other secrets are still hiding in there, just waiting for us to find them?